The biographer of Pasteur says, but you have to understand the high-pressure environment of French academia. There's, on top of it, he did human testing with his rabies vaccine, and when people died, he buried it along with the people. The people died, and he didn't want to mention that his rabies vaccine hadn't worked because that would lose him money. So he hid that. And in academia, you have to report when you do something wrong so other people don't kill people too, right? We had a vaccine in record time, under a year, and that'd never been accomplished before. From that perspective, defeating COVID was an extraordinary thing. We were also extraordinarily lucky because the mRNA technique that had been developed, that the COVID vaccine largely depended upon, came from Katalin Karikó, who had been demoted, fired, threatened with deportation by the Department of State because no one saw a future in the research she was doing. And we were really lucky. She's not of the sort who went, you know what, screw all of this. I want to go be a florist. We see it with Ignaz Semmelweis and we see it with Joseph Lister, who I discuss in the book, both of whom talked about bacterial infection in medicine and were just vigorously attacked. Semmelweis was destroyed for it. Lister was forced into exile for 20 years because he said, you know, this activity of using a scalpel encrusted with blood to show my station as an experienced surgeon might not be a good idea. Other people went, how dare you say that? Scalpels encrusted in blood are the sign of a capable surgeon. That can't be a problem. We need to be having the conversations rather than destroying and exiling people.
Hi, everybody. It's Michael Shermer. It's time for another episode of The Michael Shermer Show. My guest today is Matt Kaplan. He's a science correspondent at The Economist. He's written about everything from paleontology and parasites to virology and viticulture over the course of 2 decades. Yeah, I get The Economist. I've been reading him for a long time. His writings also appeared in National Geographic, New Scientist, Nature, and The New York Times. He's the author of The Science of Monsters, The Origin of the Creatures We Love to Fear, and Science of the Magical, From the Holy Grail to Love Potions to Superpowers, and co-author of David Attenborough's First Life, A Journey Through Time. He completed a thesis in paleontology at UC Berkeley and one in science journalism at Imperial College London. In 2014, he was awarded a Knight Fellowship to study at MIT and Harvard. Born in California, here we are. This is where we are, by the way, Matt. I bet you missed this. I don't want to tell you what the weather's like today. It's like 80 degrees today.
I don't want to know. It's gray and drizzling outside right now.
Excuse me. He's interested in why do some scientific discoveries get pushed forward while others stall? And how can science work better so we can solve our most pressing issues quickly? In his new book, here it is, I Told You So, Scientists Who Were Ridiculed, Exiled, and Imprisoned for Being Right, Kaplan highlights the trailblazing scientists who fought for their revolutionary ideas to be accepted, from Galileo, Pasteur, Darwin, to Nobel laureate Katalin Karikó, who was fired when on the brink of discovering how to wield mRNA. Well, that's been in the news a lot. Science is capable of huge feats, but by looking at its past, we can see how to make it operate best today. All right, Matt, nice to see you. Longtime fan. I'm glad you wrote this book. I stalled for 2 days so I could finish reading the book on audio. I listened to the whole, I think it was at 1.4 speed. I think it took me 9 hours. So that was 2 long bike rides in the warm heat, and then a lot of driving and walking my dog and so on. It's a great story. You're such a good writer, which is a difference between a journalist and science writer and a actual scientist. Some of the scientists I get on this show, they just can't write. They think they can write, but they can't write. So you're a good writer. So thank you for writing such a great book.
Well, it was a real joy to write it. And, you know, it's not about being a good writer or a bad writer. It's about being a writer for the specific audience that you're writing for. I mean, I know phenomenal scientists who write phenomenal papers in Proceedings of the National Academy of Science or PLOS or Science or Nature. And, okay, fine. That's not meant for the general public to be reading. And it's about writing for the people who are reading it.
Yeah. Well, The Economist is fairly high level of writing, though. I mean, in journalism, and all of their articles are written at a pretty high level. Anyway, so I guess the first question is what's the problem with science today? Just kind of give us the overall big picture, maybe starting with the replication crisis in 2010 or so, and then if you want to go through COVID and the pandemic and all the crazy stuff that happened there.
Yeah, sure. Well, I mean, There are a lot of problems, right? And we're all aware of them. But it really started to hit me. And I think I had hit my state of maximum exasperation around 2020. I had a 4-year-old running around the house, no school. And I was talking to a researcher, an immunologist, who had some wonderful ideas about dealing with COVID and what we could be doing and why people were dying. And I said, I was drafting an article about this topic at the time. And she said, "Oh, you can't quote me on this." And I said, "Why not?" And she said, "Matt, this is immunology. And let's face it, I'm a woman." And I thought, it's 2020 and we're still having this conversation. This is, and let's not forget the damage to the economy and the number of lives that are being lost while you're talking about ideas and you can't discuss them. And this followed from a conversation that I had 3 months earlier with a PhD student who said, I really don't feel comfortable having you quote me because my ideas clash with those of my research supervisor. And if they were to come out, he could fire me, and I really don't want that to happen. And this wasn't new to me. Look, I've been doing this for a long time. And if you've listened to the book, so I start out at a paleontology conference in 2014, where I had people screaming obscenities at this young woman who had done good work. And the reason she was being screamed at was because her ideas challenged a cherished notion in the community that a lot of people were tethered to. She was doing what she was supposed to do. She was asking questions and exploring. And rather than engaging in good-natured debate, and let's be honest, we're supposed to be skeptical, as you love that word. We're supposed to ask questions. We're supposed to doubt. But when the gloves come off, it doesn't do us any favors. And so I thought, okay, I was stuck at home with the 4-year-old. So I thought, how long has this stuff been going on? Is this a modern thing, or does it go back? And so I started digging. And as I dug deeper and deeper, I realized, okay, the ecosystem has changed, but many of the issues that we have today have been extant in science for decades, in some cases, centuries. You could go all the way back to Galileo, and I do, as you know, he makes his appearance, like some say obligatory, in the book. But we have issues in the structure and function of science that have been there for a long time. And I found it very interesting to go back to the Victorian era and earlier and say, okay, these issues have been here for a long time. How did they get resolved then? How could they be resolved now? What could we do to systemically make science operate better? And so that's what the book's really about.
Yeah. Well, on that, on the COVID issue, since you covered that in such detail, looking back now from 2026, what do you think we got right? What do you think we got wrong? We, the scientists and in scientific community and medical institutions, the CDC, Fauci, and so forth, versus and what we got right and wrong. But then also, why did it take so long to correct the errors? The meme you hear is, by the fall of 2020, when Jay Bhattacharya and his colleagues issued that Great Barrington Declaration, reopen the schools and restaurants and so on and so forth. It looks like they were right in hindsight, but was it hindsight at the time? Was it just mass confusion? We didn't know, and if you want to go full conspiratorial, they locked us down to take away our freedoms and so on. And, that goes a little far.
Yeah. Look, what we did very, very well, and this goes straight up to the very beginning. Researchers in different parts of the world. I know Eddie Holmes personally. He's now based in Australia, but I used to work with him on influenza research way back in 2007, 2008, possibly earlier. And Eddie Holmes got sent all of the genomic information on COVID-19 within minutes of it being identified by the team in China. This was against what the Chinese government wanted to have happen. They really wanted to keep a lid on all of this. And that it got to Eddie was hugely important, because then it got shared, and you had researchers all over the world setting everything else aside to say, okay, let's understand this thing. And then, we talk about all the problems, and there were lots of problems, right? But my job during the first 2 weeks of the pandemic was, so can we create a vaccine for this thing? And the evidence that I had from doing, 2 weeks of research from home was, this doesn't look good. Measles took this many years. Mumps, rubella, this many years. Whooping cough, this many years. No matter how you looked at it, everything took years. It was bad. And so I reported into my editor, I don't have any good news for you. It's going to be years before we can create a vaccine for this thing. And lo and behold, within 6 months, we had extraordinarily promising results. And so the engine of science, which is pretty generally a clunky old engine that is not terribly efficient, kicked itself into gear in an extraordinary way. Governments pulled out all of the stops, some of them not so great, because when you pull out a lot of your safety restrictions and a lot of your buffers, things happen faster and sometimes more recklessly than we would like. But we had a vaccine in record time, under a year, and that'd never been accomplished before. So from that perspective, defeating COVID was an extraordinary thing. We were also extraordinarily lucky because the mRNA technique that had been developed, that the COVID vaccine largely depended upon, came from Katalin Karikó, who had been demoted, fired, threatened with deportation by the Department of State because no one saw a future in the research she was doing. And I mean, we were really lucky she's not of the sort who went, you know what, screw all of this. I want to go be a florist. Because then we really would have been in trouble. I mean, you can make the argument someone else would have come along and done what she did. And okay, that's a fair argument. I mean, look at Charles Darwin. Charles Darwin was hot on the heels of the methodology behind natural selection. And Russell Wallace was right there with him. The idea, you could argue, was prime for the time, but you still had Katalin Karikó who had developed this, and who knows what would have happened if she hadn't had that work being developed, and where we would have gone.
This was the mRNA research that led to the vaccine? Yeah. Right. So she was going up against a paradigm that said that's not going to work, or we can't develop it in time, or...
Well, the real problem with mRNA was no one understood that when you tried to mobilize mRNA, it was attacked by the immune system and became unraveled almost the second it got into the body. The huge issue was being able to cloak it with proteins that told the immune system, don't touch this, because she could get mRNA to do anything she wanted in the Petri dish for ages. And she could get it generating any kind of protein she wanted. So using her words, not mine, she became a god of very limited capacity. She could create anything in the Petri dish, but if you inserted it into the body, it didn't work. And through a chance encounter with Drew Weissman, who was an immunologist at Penn at the time, I mean, they were both at a photocopy machine in the library on the same day. He saw what she was photocopying and said, so what are you working on? And she was talking to him, and they chewed the fat, and they were kind of rivaling each other for access to the photocopier. And eventually he said, well, it might be an immune reaction that's causing the mRNA to unravel in the body. And so they collaborated and ultimately worked out you had to use certain proteins on the mRNA to stop the mRNA from being disentangled in the body so you could effectively weaponize it. And I mean, this was huge. And it was also a stroke of luck that you had that kind of collaboration occurring, but that collaboration wouldn't have occurred if she'd been deported back to Hungary by the U.S. Department of State earlier on. They never would have met, and maybe it would have come up somewhere else. Maybe it wouldn't.
Interesting. Well, on that and your book, who's going to love this book is all the people that send me alternative theories of physics. Newton was wrong and Einstein was wrong, and I've worked it out. But also along these lines, somebody like a Robert Malone who goes on Rogan and says, these vaccines are a terrible thing. They cause myocarditis. Or Brett Weinstein's on there saying, I read this paper that said 17 million people died from the vaccine. And then when I challenged him, I was just on his show for my book tour, and I brought that up because I never said that. I just said I read this paper that said, it could have. It was like, yeah, but you and Rogan talked about it for like half an hour. So, I mean, what people are hearing is like millions died from the mRNA vaccine. What? And
I know.
I don't know. So, what do you make of all that?
Well, I make of that is that, everything in moderation. I'm saying you can't take the gloves off. You can't, as I saw at this conference in 2014 with this young female PhD student, ripping somebody apart because they've put up a poster that challenges the methodology that you've been using. In this specific case, Michael, I'll explain. You may remember from the book, you may not. Researchers from all over the world. I'm a paleoclimatologist by training, so paleontology is kind of second nature to me, and I cover it all the time. Researchers for years had been publishing papers demonstrating that they could look at these color pigments in fossils, and they could look at the microscope at fossils that had been smushed into the mud, and they could look at the feathers under the microscope and say, I can work out what color this feather was. So then they would recreate T-Rex with feathers on the cover of a big journal, splash it out there. There are a lot of people who are getting a lot of attention and a lot of research funding to support them with doing work on this sort of stuff. And this PhD student said, well, hang on a second. I would like to bury these feathers in a garden for a year, dig them up, and I want to look under the microscope to work out whether I can still see the color proteins. And she buried them under different kinds of environments. She buried them in different types of sediment to give her maximum longitude to be able to say, look, it might be possible to see the color pigments. And she could not differentiate a year later between color pigment proteins and bacteria. It just wasn't feasible. They looked indistinguishable to her. And so she put up a poster saying, I did this. I can't tell the difference. She's not saying you're wrong. She's saying, I checked, which, by the way, up until very recently, this was a typical thing for PhD students to do. It was really common for PhD students to replicate past research or to run a basic experiment, just double checking that what we think we know, and asking those questions. This is healthy. This is really important to science. And rather than saying, well, hang on, did you do this or did you do that? We've got folks who are on the conference room floor using terms about female genitalia at very loud volumes that I heard as I walked into the poster session that evening. I had a PhD student in tears. Her PhD supervisor was pretty damn close. It was a full-on battle. And the science doesn't do itself. I remember writing about the article. I called it, What a Flap. You get the joke. And, and I really, aside from talking about what her research was, which I thought was interesting because we should be asking questions, I thought it was rather shocking that we had this kind of mob, an angry mob, coming for her on the floor of the conference. And the behavior got so bad at a follow-up conference in Europe that actually the Society of Vertebrate Paleontology had to publish rules of behavior for attendees of its conferences so that this would stop. Now, and I go back into history in my book and I point out that Oliver Wendell Holmes, many people will know as a poet. He was an outstanding writer. Oliver Wendell Holmes Sr., not the jurist on the Supreme Court, although he was an amazing guy in his own right. Wendell Holmes Sr. Was looking at a disease called puerperal fever, or also known as child's bed fever amongst Americans. And it was horrendous. It killed roughly 1 in 10 women. If women caught it, it was a death sentence. They were dead. It was only second to tuberculosis in diseases that killed women. Tuberculosis killed moderately more, but not that much more. Puerperal fever got almost no attention, while tuberculosis got a lot of attention. And the reason was because men didn't get puerperal fever because men didn't deliver babies. Wendell Holmes really wanted to understand what was going on. He was using a new methodology that he had learned in France to keep notes and monitor who got the disease, what the conditions were where they got the disease, rather than doing what people had done for hundreds of years, which was, which way is the wind blowing today? Is Mars in the ascendancy? Is it a crescent or a full moon? You laugh, but this was medicine for, centuries. And Holmes picked up that if people, doctors, went to check out patients in a morgue in the morning, because that was a standard practice for doctors all the world over. They would go and look at their patients in the morning who had died the previous day to try to understand why they had died. If they went to the morgue and then attended patients later on, those patients were very likely to get puerperal fever. Similarly, if those doctors dealt with patients who had a disease called St. Anthony's fire, where your skin got all flared up, patients were very likely to get puerperal fever, and certain doctors tended to have the disease follow them. So he worked out that something was going on between handling corpses and certain diseases, and then the doctor delivering a baby from a woman later that day. Now, standard practice at that time was for, obstetricians to stick their fingers into the uterus and feel if the baby's head was there before the baby came out. We still do that to a certain extent today because, without having to initiate a cesarean, a good obstetrician can go and feel if the baby has, we'll see it through ultrasound now, but they can get the umbilical cord, if it's going to strangle the baby, off from around the neck with the right maneuvers. So sticking your hand in the uterus in critical conditions is still done today. It was done all the time back in the day to understand whether or not the baby was about to deliver, whether the baby was right in position, or whether the baby needed to be rotated, because they could even manage that. There's a lot of hands in the uterus here. And if you were handling corpses early in the day, you're basically taking corpse material and inserting it into the uterus. And Wendell Holmes didn't understand exactly what was going on because Louis Pasteur hadn't come along yet and worked out that there were microbes in the world that caused disease. But there was something there, and he said, we need to stop. We need to separate out the process of handling corpses and certain diseases and obstetrics. And these two researchers, what are their names? Hugh Hodge and Charles Meigs, they were like prominent obstetricians at the time, went absolutely ballistic. They went, how dare you tell us that our hands are dirty? We are gentlemen, sir, and our hands cannot be dirty. And they went on. It's hysterical because he published in a number of academic journals, and the attack got really nasty. So nasty that instead of using terms like what I heard on the conference floor, referring to female genitalia, they said, these are physonless dreamings, which is apparently really hitting below the belt in Victorian language. Physonless dreamings, Michael, physonless dreamings. And it was so bad that Oliver Wendell Holmes had to basically give up, step away, and he turned to literature and really never pushed the matter again. And just think about the decades that went by of women dying because no one did anything because these two fellows just ripped Wendell Holmes apart.
Mm-hmm. Well, the deeper issue here in the philosophy of science is, Popperian falsification versus a more Bayesian verification. And so supposedly science works by trying to falsify or test hypotheses, but in fact, it really doesn't work that way, as you show in episode after episode in your book. Really, once the consensus is reached, no one's really trying to falsify it. They're just trying to gather more evidence to continue supporting that. So when someone comes along and says, what about this right here? They're not greeted with open arms like, hey, we might be wrong. Why is that?
Yeah. Well, so there are a lot of reasons for that. Today, a big part of it is because our livelihood depends upon continuing to get research grants. And if you've built your entire lab around an idea and then that idea is proven wrong, that can be threatening to you. Mm-hmm. There's also the fact that as we get older, Michael, we don't like change very much. And it's harder for people who have been working in a field for 20, 30, 40 years to say, oh, really? I dealt with it at The Economist today. We just had a meeting about using AI for citations and how to use this new tool to support the fact-checking process. And I get how it's going to streamline things. I really do. But I'm sitting there in the meeting thinking, I am a little uncomfortable with this. Do we really have to? Why can't we just send the papers to the fact checkers like we always have? And,
Yeah.
And I get it. It will save time in the long run, but people don't like change. And I was sitting with Venki Ramakrishnan just 7-8 months ago. He and I were talking, he's Nobel laureate in chemistry, wrote Why We Die. And he and I were discussing these issues in science. And he said, it's important. Well, he didn't exactly say this in exact words, so it's not a quote, but it's important that people step down from their research after many years because it allows fresh minds to step in and ask questions. The longer we're there, the more entrenched we get, and the less likely we are to ask questions and be open to change. So there's that factor too. But it's important for the old guard to ask questions. Critically important. We need to challenge. When someone steps in and says, hey, I looked at this map and it looks like North America fits with Europe and it looks like South America fits with Africa. Is it possible that they were once together? Rather than throwing sharp objects at that person, it might be worth saying, that's interesting. Do we have evidence to support that? Well, yes, we do. Look, rocks collected on the coast of South America match the rocks that are coasted on the coast of Africa. That's fascinating. Maybe they were once together. So, rather than going nuts and attacking people who ask these kinds of questions, it's good to be skeptical. It's really important to peer review and science that we say, hang on, are you sure? Let's run that again. But let's not take the gloves off and beat the ever-loving shit out of them or call them terrible names on the conference floor such that the PhD student quits science and never touches the field again.
Now, in the case of Wegener, who you're talking about there, it was decades before it was accepted that he was right because there was no mechanism for it. So to what extent can you have observations and a theory based on that, like Darwin's theory of natural selection, but he never had the genetic mechanism for how this works, and his speculations about gemmules and so on turned out to be ridiculously wrong. Or in the case of Wegener, he was right, but it wasn't until the 1960s when they did all the drilling that you mentioned and the magnetic shifts and all that stuff and the sea floor spreading, in which, because the argument against them was, they sort of look like they could match, but what in the world could cause an entire continent to move? That's impossible. Okay, so this is a problem. So, like a lot of the paranormalists I deal with, say, look at these results. It looks like people can read the backs of playing cards or read other people's minds. Okay, well, the data's on that is pretty mixed. But one counter that we always have to it is, but what would be the mechanism? I mean, how would my thoughts go into your brain, short of some quantum field thing or whatever? That's always been a sticking point. But then the counter to that is, but you can have a correct theory like Darwin had without the underlying mechanism.
I mean, and it's important to take that take that theory and say, okay, look, do we have everything for this yet? No, we don't. Does that mean we shred it? And that's the critical point. If you can say, look, this is an idea that might have merit. We don't have the mechanisms yet, but we have enough history in science to know that we often have good ideas that don't have the mechanism yet. Rather than put it into the shredder, or worse, immolate it at the stake, take it, shelve it. It's there. We know it's there. It might be proven wrong. It might develop its mechanism later on. We don't know, but it should be part of the literature. It should be part of the conversation. And the person who came up with it should not be lynched.
What do you think about the idea, since you opened with Jack Horner, and I know Jack really well, that it helps to be an outsider? Jack was always an outsider. He had dyslexia, couldn't finish his college degrees, so he's just going to work on his own. I'm just doing my own thing here. I don't really care about the whole academic process. I'm going to go out there and dig fossils up and think about them on my own. That turned out to be a really useful strategy for him. But, worked out well that, he made some discoveries and got the funding for it. But if you're just some, lowly grad student in a lab and you're not Jack Horner, being made famous by Steven Spielberg, how are you going to get the funding? Well, I got to go through the system. And then you're locked into this, paradigm restrictions.
Well, I mean, Jack got his Genius Awards before he was anywhere near Jurassic Park. Jack was a curator at a museum, and he kind of tagged on to a bunch of papers and got more and more attention for writing stuff, or at least having ideas that were in papers that really, really got a lot of interest. So Jack was an outsider. He started small. He got the fellowship. He got a lot of money to explore his pretty left field ideas, to use an American phrase. And that's a good thing. It's important to give ideas that haven't had their moment yet funding to explore. This is why I talk about the Howard Hughes medical funding so much, because they do give people 7-8 years to, first of all, try something that might be out there a bit. And more importantly, because they give them time, they give them the opportunity to be wrong. They can try something and it doesn't pan out. They can try something again. It doesn't pan out. They get years to try things that don't pan out. I mean, and as I cite in the conclusion of my book, Howard Hughes grantees do not get the same number of top tier papers that NSF publications do. But the papers and ideas that they do have are extreme top tier. They are really big breakthrough ideas, whereas NSF stuff tends to be more run of the mill. So we're getting more of that blue sky thinking by giving people time and being patient and tolerating failure. And we've got into this mode in science today where we're very intolerant of failure. Oh man, they got that grant and it went nowhere. We're not going to give them any more money. I got real issues with that. If you try something and it doesn't work, as long as it was well thought out and it was genuinely put together properly, if it doesn't pan out, that shouldn't blacklist the scientist from funding in the future. That scientist, if they did give it an honest effort and they did try things, they should be given another chance to try it again. We shouldn't be throwing people out for failure. In fact, it's, I think, quite counterproductive for us to do that, because it leads people to put forward proposals that are a lot more cautious. And to solve the big problems of today, it doesn't help us very much if we start only putting forward modest proposals for research.
How do you think about public money funding science versus private money? Here I'm thinking of like the X Prize or the Kramer Prize. I don't know if you know the story of Paul McCready, who founded AeroVironment, who really invented the whole research on and manufacturing of drones, small drones. And I knew Paul pretty well. And, you know, he had just gotten his PhD in engineering from Caltech, started a company, bought a home, started a family, had no money. And then there was a rich British industrialist named Kramer who said, I think it was 100,000, maybe it was 250,000. This was back in the 70s, for anybody that could build a human-powered airplane that could cross the English Channel. First, do a figure 8 in a parking lot somewhere, and then cross the English Channel. So Paul went for that, and he won. He made the Gossamer Albatross, and that was the funding for his research. So, I mean, but most people, again, they're just in the system, got to write a grant to the NSF. Oh, I have a funny story for you, because you probably know Stephen Jay Gould, since you were in paleontology. He once told me that he writes so many books because it would take him the equivalent amount of time to write a grant proposal. So he's like, I might as well just get an agent and get a big advance for a book and write a book.
Yep. I mean, and that's true. I mean, the number, you look at each grant that gets awarded and you calculate the hours that each researcher who applies for that grant had to put in. And in most cases, for a single grant, you are looking at years of hours that are consumed by researchers trying to get that pot of money. So, I think that's really telling. To answer your specific question about private versus public, I think they both have a place. So public funding is going to go towards certain things. Private funding is going to go to other stuff. I'm going to be at a big conference in Florida at the end of February, where I'll be interviewing one of the chief scientists at Colossal, which is the private organization that wants to bring the woolly mammoth back so that I can go up and cuddle it. They already have dire wolves, Michael. They already have dire wolves. And, paleontologist, right? Journalist, yep. Paleontologist. And of course, I have the words of Ian Malcolm echoing in my head. Yeah, John, just because you should doesn't mean, just because you could doesn't mean you should. Not that I believe the woolly mammoth is going to get out and start eating people. Although the dire wolves, you never know, right?
Yes.
And, okay, look, I mean, as a paleontologist, I don't think there's a place for us bringing back a woolly mammoth to walk in the tundra that probably won't exist in 20 years. But, and this is a giant but, the technology that is used to reconstruct a mammoth or a dire wolf is the technology that could bring, is it the Sumatran or the Indonesian rhino, of which there are only 43 left in the world? I can't remember which one it is. Is it Indonesian or Sumatran?
I don't know.
Can't remember. But, whichever, it's the rhino that wanders in the jungle, Michael. That rhino currently is listed as eating something like 46 or 47 different species of fruit that live in the jungle. And of those, more than half depend upon the rhino for germination. If they don't go through the rhino butt at the end, they don't germinate, which means when the rhino goes, those, 24 plant species will go extinct shortly thereafter because they'll stop spreading. So, using the technology that a private company is developing to then help us recreate a species that is integral to maintaining an ecosystem, which, by the way, people depend upon, is very important. And so through its work and the wow factor of let's bring back a mammoth, which I may not be terribly supportive of, you are paving the way to bring back the Tasmanian tiger, supporting populations of rhinos that are on the brink, bringing back potentially the dodo, which may or may not still have an ecosystem that depends upon it. And so from that perspective, you're getting money that wouldn't come into the scientific community anyway to support research that's integral, not just to ecosystems, but ultimately to human well-being. Because if we don't have big chunks of the planet that are wilded properly, we've got problems. Never mind, the bioprospecting that can occur in these places to create new medications to help humanity. Just having those ecosystems is important for our survival. So, and that's money, people saying, gosh, I got $1 million. I'll throw it at the recreation of the mammoth. That's money that would not normally go to science. So I think there's a path here that's important, but it doesn't for a minute undercut the importance of public funding of science, because it's absolutely critical. And we need to change the way we do a lot of our public funding of science.
All right, let's talk about the replication crisis. You talk about big journals don't want to publish replicable studies because we already published the original one, and we need original stuff because we need to make money and so on. So my favorite example of this was back to the paranormalist who always would say to me, why don't you believe in ESP and so on? It's like, well, show me a prominent scientist from a major university who publishes in a major journal some findings that shows the ESP or the paranormal is real. Well, along comes Daryl Bem, who's a real scientist who publishes in the Journal of Personality and Social Psychology, one of the most cited journals in the social sciences, of his ESP research, right? So this gets a huge play. Of course, we covered it in Skeptic. And then Stuart Ritchie and Richard Wiseman try to replicate it, and they can't. So they fail to replicate, and they send the study to the same journal that says, we're not interested.
I know.
I mean, that would be the Popperian falsification system at work.
Yep.
Look, we falsified it. And they're like, not interested. I mean, this seems like a colossal shortcoming in science.
It is a major problem. And and it's been a problem for a long time, but it's getting worse because the bandwidth, the attention that we have for papers is limited. And these journals do not have the incentive to publish something as a replication, but it is integral to what we do. So how do you get around it? And the only way I can see getting around it is to change some of our funding mechanisms to favor particularly PhD students or junior researchers with doing some replication work. Otherwise, we're creating a house of cards, Michael. The research that we create, if it can't be replicated, what are we doing? Yeah. I mean, and that's before we even get into the issues of fraud. I mean, I as I point out in the book, we start with Louis Pasteur, and I love it. The biographer of Louis Pasteur wrote, "You have to understand the highly competitive environment of Victorian French science to explain his behavior." Because as I point out, Louis Pasteur. Yeah, so Louis Pasteur was desperate to create the rabies vaccine. He wanted to create the vaccine for chicken cholera, which wasn't related to cholera in people, but it looked like cholera in people, so they called it chicken cholera, and it just devastated the poultry industry in Europe. And for his work, the chicken cholera stuff, he depended upon research by a country-based veterinarian named Henry Toussaint, and Toussaint had done pretty much all of the work demonstrating that if you killed off the bacterium, or mostly killed off the bacterium before injecting it into chickens, the disease would create resistance in the animal and ultimately render the animal, uninfectable. And Pasteur had based his entire argument on how to create a vaccine around the idea that you use oxygen to weaken the bacteria so that the animal won't get the disease when you inject them with it. But it didn't work, and he couldn't get it to work in his lab, yet he had already loudly criticized this country bumpkin veterinarian. And so he, in his journal, he lists that he ultimately adopted Henry Toussaint's mechanism of using destruction of the bacterium before creating the vaccine rather than weakening with oxygen. But then he lied about it when he ran his tests so that no one would know that Henry Toussaint was actually right. And Henry Toussaint was eradicated and died, unknown. And he did pretty much the same thing with the rabies vaccine, because Pierre Gaultier had done all of this work with the saliva of rabid dogs and demonstrated that if you took rabid dog saliva and then you injected it into sheep rather than and then transferred from the sheep back into other animals, by moving between animals, you would weaken the virus over time. No one knew what the virus was. They didn't even know that viruses were different from bacteria. But Gaultier had demonstrated that if you went from one animal to another, it could change the virulence of the virus. And Pasteur said, wow, that's amazing. And he created a vaccine by ultimately going to monkeys and then re-injecting into animals and demonstrating that if you inject into the monkey before going into people, you can create the vaccine. But again, he destroyed Gaultier and didn't cite him at all in his work in the end. Originally, he did cite him, but he only cited him as being wrong. Generous, right? And the biographer of Pasteur says, but you have to understand the high-pressure environment of French academia. And there's on top of it, he did human testing with his rabies vaccine, and when people died, he buried it along with the people. The people died, and he didn't want to mention that his rabies vaccine hadn't worked because that would lose him money. So he hid that. And in academia, you have to report when you do something wrong so other people don't kill people too, right? So, we should be talking about this stuff, and Pasteur was deeply unethical. And so you have the fraud going on back then. We have fraud going on now, and it's very much because of the high-pressure environment that we exist in today. People are desperate for funds. And so if the results aren't exactly what folks want, they'll massage the numbers. Hang on, Matt. Let's distinguish between outright fraud, like you're describing. I'm just going to make up numbers and fill them in my file, versus I'm just p-hacking. I got to get a 0.05 level. I'm at 0.06. If I throw out this one little data point, it comes to significance. Yeah. Or file drawer problem. I ran 6 experiments. I got 3 were significant. I'll just not even report on the others. Things like that. Yeah. That doesn't seem as bad as I'm just making up numbers and filling them in. or as bad as taking someone else's research, erasing them from history,
Yes,
and then engaging in
right.
character assassination, right?
Right.
I mean, because I think we can all come together and say that stealing someone's work, lying about it, and then bad-mouthing them once you've got the glory is probably wrong.
Yeah, yes.
We can agree on that, right? Because that's not nice. And yeah, there are different degrees. I agree with you wholeheartedly. I mean, you look at medical research now and the number of papers that are retracted. It was like 18,000 in 2023. I think I cite that number in the book. And, okay, some of those retractions are because people are human. People make mistakes. Errors are acceptable. But that number of errors is not acceptable. And especially when you can trace it back and see that people have filled stuff in to make their results significant when they were not. This isn't cool. And at the moment, we don't have a mechanism really for checking it or going after people when they are found to be highly likely to have engaged in unethical behavior. Because currently the most you get is, you've been put on administrative leave by the university pending investigation, et cetera, et cetera, et cetera. I mean, but think about it. I mean, you take $500,000 for a research experiment and you run it and you lie about the results by massaging the numbers. And then that opens the door for you to get another $500,000 to do more work when actually your numbers weren't necessarily good the first time around. That's now $1 million that have gone to research that probably, okay, the first one you can forgive. You gave it a shot. It didn't work. But the second shouldn't be there. And what's worse is other people look at your work. They look at the p-values and say, oh, those are significant. I want to follow up on that and run an experiment. So I'm going to apply for a grant for $500,000 to run an experiment to follow up on your work that I don't know actually had its numbers massaged. That's not cool. And so it's like a lie. The lie just builds over time and expands. I only say this because I see truth in big, bold letters behind your head. And so the issue is you've got an expanding problem where the money keeps going. And if you walk into a bank and you steal $1 million, you go to jail. You initiate an activity like this, which I would call a crime, that leads to millions of dollars of funding being used recklessly. That's not cool. And there currently is very little penalty for that. And there's very little mechanism for detecting it. So I take umbrage with that. And I take umbrage in the same manner that I take umbrage with Louis Pasteur. I mean, we can all come together and say that wasn't cool.
Mm-hmm. Mm-hmm. Why do journals charge so much money for articles, for example? Let me just riff on this for a second because it really bothers me. Because I'm not at a university anymore, so if I want somebody's article, if I go straight to the journal, it's like $90 for this short review of a book or whatever. And I guess the university normally pays that because professors don't make that much money. Or if you publish in a journal, like I just saw when I submitted an article, we will print this in the print magazine for free, but if you want it online, it's like $3,500 that I would have to pay. Now, presumably my university would pay if I was an academic or something. This is all research mainly funded by the professors are already getting paid. So why is it that the journals are charging? And did they really have to do this to stay in business? I mean, is it really like a for-profit company?
Yeah, well, I mean, this is a good question. I mean, so it goes back to the history of academia, right? Scientists would have an idea, they would create a paper, and then they would offer it up to a journal to publish if their group of peers viewed the paper as worthwhile. And getting published in the reputable journal generates that academic credit that ultimately leads the scientist and their university to get gravitas, right? They get that prestige. And then the university says, hey, it's great having you here because you bring us prestige. So we're going to pay you more, or we're going to keep you here, for the end, till the end of your days, just keep exploring ideas because you're worth having. We don't live in that environment anymore. And we've got capitalism seeping into it, and it doesn't help. We've got to change the way in which the funding mechanisms operate. The funding for academic checking, and this applies to replications, because there should be funding for people to repeat stuff it shouldn't just be random what we're repeating. We should look at stuff and say, oh, wow, look at all these grants that are being put out to follow up on research that was published 3 years ago we look at Web of Science and we can't see that that's been replicated yet. Someone should replicate that. We should replicate that before more funding goes out. Certainly, AI can analyze the system and tell us that paper has a lot of stuff depending upon it, and no one has run it again in a neutral lab. It would be worth doing that now before we go too much further. That's an easy thing for us to do. Similarly, we should have better peer review that should be funded, because right now our peer review depends upon someone saying, yeah, I have a spare hour, I'll read that paper, but they're not really compensated for that. And compensation for particularly academics in the early part of their career should be present to help them to be able to keep going. And there need to be safeguards put into place so that we don't have biases in the system from the very beginning.
I loved your discussion on peer review where you encounter a paper you don't think is very good, but he cited me 5 times, so I'm going to approve this because that'll get it into the publications and my H index will go up.
It drives me crazy.
That's too funny. And it's, they're supposed to be blind so that, you don't bury somebody you don't happen to like. But I can always tell who the author is because they're the most cited one in the bibliography.
Yeah. Well, not always, but yes, very often. And that is a major issue. And that's where you have to do with strength of numbers and where you can effectively bury 1 or 2 peer reviews to say, most of these are positive. Here are 2 negatives. If we've got that mix, do we have a policy to ignore that one withering review? And those sorts of things should exist. And parallel with them, I talk about the golden ticket methodology, which not particularly Roald Dahl fan, but is called the golden ticket because when you're doing a committee consideration of, for example, a paper proposal or fund or grant proposal, you have lots and lots of papers that experience death by committee, where there might be one person who's really excited about the paper or 2, but the vast majority are lukewarm to it because it's too far out there or it's too specialist and many people on the committee don't understand it well enough, like the one person who gave it a 5-star review and said we should go for it. And this notion of giving each committee member during each cycle 1 golden ticket, effectively an ace, to say, you know what, screw the lot of you. I don't care that all of you think that this isn't worth pursuing. I think it's cool. I'm playing my ace on this paper so that it gets funding. I think that's an interesting concept, especially if we have mechanisms in place to prevent the person on the committee from applying their ace towards somebody they know, which is something that we can do. And also with the small print that says, look, if you do it, you'll be removed from the committee in the future. So don't do that. That kind of thing. There need to be repercussions. But I think doing that will open the door for us to fund research that is more creative, more novel. Yep, there might be more dead ends, and that's okay. Failure is something we have to get comfortable with. And we're not comfortable enough with it right now. We keep thinking that if we give them grant money, they have to come up with some big idea that paves the way for the next big discovery. It's important that we understand that a lot of the stuff we fund isn't going to go anywhere. And if we don't get creative, if we don't start supporting creative ideas that are out there, we're not going to make the kind of distance that we need to make to solve our big problems.
A lot of science critics will read your book and go, you see, science is truly broken. Here's all the things that are wrong with it. Yeah. I'm reminded of the creationists in the 80s, pointing out, the scientists fell for a Piltdown man and they misdated this fossil and they misidentified that fossil and so on. And Gould always pointed out, yeah, but it was the scientists who discovered those errors and frauds and mistakes and so forth. To what extent do you think science really does work pretty well in a self-correcting way?
Science has the infrastructure to do its job. It's there. It's in its DNA. I mean, to take this full circle back to mRNA. From the very beginning, we had the process of considering, debating in unfortunately a gentlemanly fashion as opposed to a gentle personly fashion. We can adopt a gentle personly fashion now, but this is the way it's supposed to work. The ideas are supposed to be discussed, debated in a civil manner, considered, and either accepted or rejected. I think up there is a middle ground that needs to be considered more often, and that is the shelving approach. We don't know what to make of this interesting idea right now. We can't support it. We can't reject it. But just because we don't know what to do with it doesn't mean we should shit on it. So let's take it and let's put it on this shelf and say, it's there. We don't know. We don't know. We should have done that with mRNA back in 2000 when Katalin Karikó first had the idea and said, don't know what to do with this. Let's put it there and just keep considering it rather than trying to throw the person out of the country and fire her from her job. This is the thing. I mean, and we see it with Ignaz Semmelweis and we see it with Joseph Lister, who I discuss in the book, both of whom talked about bacterial infection in medicine and were just vigorously attacked. Semmelweis was destroyed for it. Lister was forced into exile for 20 years because he said, this activity of using a scalpel encrusted with blood to show my station as an experienced surgeon might not be a good idea. Other people went, how dare you say that? Scalpels encrusted in blood are the sign of a capable surgeon. That can't be a problem. We need to be having the conversations rather than destroying and exiling people. So my argument against the people who are going to say, oh, see, look, he says science is broken is read the damn book. Because if you read the book, you'll see that that's not what I'm saying. I am emphasizing that science has gotten us a long way. It is a functional engine of discovery. It is a clunky engine of discovery. We can fine-tune it. We can fine-tune it in some really clever ways, many of which don't involve vast sums of money, but a restructuring of the way we do things and accepting some failure, which is what we're currently allergic to, and that's a problem.
Mm-hmm. All right, I know you got to go, Matt. Last question back to where we started. How do you know which of these alternative, new, challenging theories to the paradigm are the right ones? Your book is mainly the ones that succeeded, the survivorship bias. What about all the people that were just wrong? And there's a lot of them. And so, we see this today. Rogan loves to have all the alternative people on his show, like alternative archaeologists that says, archaeologists got it all wrong, or the Weinstein brothers who's, challenging physics or biology or whatever. Maybe they're right, but how do you know? I mean, when you encounter these, how do you know, okay, this guy's probably way off. I don't need to read his paper. Or, does the consensus usually get it right and the alternative guy is probably wrong?
Well, there are two answers to that. The first one is, as a science journalist, so I stick to the languages that I know. I'm a paleoclimatologist by training, so I can dip into climatology, I can dip into paleontology, I can dip into biosci, and over the years, I've read so many academic papers, I can dip into most things comfortably, read the paper and say, yeah, okay, I get it, and I think that makes sense. Then I'll go to the results section and say, do those chi-square values add up? Do those p-values add up? Does this look good to me? And then I look at the citations. And I say, do those look convincing? What are those? Are those mostly your books? Are those mostly your allies? Or are you citing other people in your field? Where is this coming from? And you ask the questions as a journalist. Does this all add up? Does it pass the BS filter? Such that I feel comfortable writing about it in The Economist and proposing it to my editors, who I've been writing for 20 years, who will say, Matt, do you think this is legitimate? Because if we get it wrong in The Economist, that looks bad. And Alok and Gilad and Jeff, they trust me to know what I'm talking about when I propose a paper and say we should cover this. So as a science journalist, you got to do that kind of stuff. With the stuff on the broader spectrum, which is the second part of my answer to your question. How do we know? How do we know if this, person demonstrating telepathy or God knows what is really onto something. Sometimes you don't. And that was the case with mRNA back in 2002. It looked like voodoo to the rest of the academic community. And it's the same thing with the feathers in 2014 with the PhD student who's saying, I'm not sure if this is bacteria or color molecules. What's going on here? We don't know. And it's okay not to know. When we don't know and we can't prove or disprove, you take it, you shelve it, and you say, okay, it's there. We need to consider it and keep considering it, and that might irritate you like a splinter. It's there. And like white blood cells attacking a splinter, it's going to create some inflammation. That's normal. That's healthy. You will get over it. And it's important for us to have those things that we can kind of consider over time and continue to throw ideas at. And sometimes they'll stick and we'll say, wow, this person who we thought was crazy, like Alfred Wegener, turns out to be right. And now his name is attached to the most important medal you can earn in geology. And sometimes people are wrong, like James Simpson, who invented anesthetics and vigorously attacked Joseph Lister to the point of nearly destroying him. And James Simpson was totally wrong about his theories of inflammation post-operative infection. So, we got to put the ideas out there. We got to keep them. We don't destroy them. You need to consider them and continue to think about them. And that's part of the process of science. We get into this binary state of it is or it isn't true. Sometimes it's in that zone in between, and that's okay.
Mm-hmm. Yeah, I always take a Bayesian approach and say never assign a 0 or 100% to anything. Could be right, so like Graham Hancock's alternative theory of the pyramids and Atlantis and all that stuff. Maybe. Could be right. I'll give it a 1% or a 2%. Then I'll update my priors. If he says, well, look, this finding, okay, I'll give it a 8% or 10%.
Exactly.
And then you don't have to fight like you're going to die if this guy's right.
Exactly. I mean, and this brings in an important point. Your shelf, as I keep talking about, can have different levels. There can be the shelf where really can keep considering this, folks. This is something worthy of constant consideration. We're not there yet. And you can have alternative theory of the pyramids. Maybe that's the shelf you don't look at very often. But let's not entirely dissuade ourselves from considering it. We might want to look at it once every 5 years and consider maybe it might be there, but you can have different levels. And I think that's a healthy thing.
All right. Good place to end. I told you so. There it is. This is a great read. And it's on audio too. Those of you who love audiobooks, give it a listen. The reader is quite good. So, all right, Matt, thank you so much.